All right, this is lesson 4.9b, and we are continuing with the same essential standards as 4.9a, and we're focusing on I can use polynomial division to find additional factors of polynomials, okay? And I can write polynomial equations if I know the specified zeros. Now I'm going to take you back and recall that if I have some long polynomial, okay, so I've given you a polynomial and I tell you x minus c is a factor, find the other factors using synthetic substitution, I would divide those, that polynomial by c, and what I would get left should have a remainder of 0, and then I can factor the rest, okay? Because just like what Mrs. Query said in the past, if I have 152 and I'm trying to find its factors, I might first divide it by 2, and then I get something that is a little bit easier to manage, okay? So we're going to do the same thing, except this time we're going to use our graphing calculator. So what we have here is this large polynomial. It's an x to the fourth, and we're going to plug it into our graphing calculator. How are we going to do that? We're going to go here to your y equals, and you're going to type in the polynomial x to the fourth minus 18x squared and so forth. And once you have entered that into your graphing calculator, you're going to take a look and see what it looks like by going and looking at the graph, by hitting graph. And it's probably not going to look this nice. In fact, you'll probably only see a portion of the graph. And then you will need to adjust your window settings. In your window setting, you will find a minimum and a maximum for each x and y value, and then also an increment. And you will have to do that you'll have to do that multiple times, most likely, right? So you might pick, I don't know, sometimes I pick 100 and 100, 100 and a negative 100 just to get a sense of where I'm at. And then I will start kind of changing my window to zoom in. So what my settings were for x were -5 to 5, and my tick marks are 1. You can see that this is 1, and then 2, 3, 4, and so forth. And then the y values that I have here are -45 for minimum and 105, and tick marks are 15. Now, why are we doing this? Why are we doing this? Well, it's similar to what we did before. Once I know a factor, which is the x minus c is a factor, then we know that x equals c, that c is a 0. If c is a 0 or a root, then it crosses the x-axis at x equals c. And so we can take this and say, I think that we have 2 roots or zeros at x equals -4 and x equals -2. Now, why do I say I think? It looks like it's right on the money, Mrs. Curry. Well, because we don't know if that's exactly -4. Maybe it's -3.92. Okay, so we're going to assume that those are potential zeros. We are trying to find all of the zeros of this function. So if I know that I have 2 of them, what can I do? I can, let me get rid of all this, it's kind of in my way. I can divide them out. And what should I get as a remainder? Well, if it's a true 0, my remainder should be 0. So if it's a true factor or 0, I should get a remainder of 0. So I'm going to use synthetic division. I have 1 in front of x to the fourth. I have 0 in front of x to the x to the third power. So we have to have a placeholder. I have 18 and -18 in front of x squared. I have 12 in front of x, and I have 80 as my coefficient. Now, I'm going to divide by -4, which is the same as x plus 4 as a factor, and this is x plus 2 as a factor. So normally we would have switched the sign if it was in this format. I don't have to switch the sign if it's in my 0 format. All right, so -4, I follow my procedure. I get 1, I multiply times -4, I get -4, I get +16, I get -2, I get a +8, I have a +20, and I get a -80. And look what I have as a remainder. What does that mean? That means that -4 is a 0. And I've just found one. Now we think that maybe x equals -2 is a 0. Well, let's divide that out. Why do I have to rewrite that in a polynomial form, let's just leave it right there. And that it's already set up for division. So let's go ahead and divide out -2. So I have, pull down the 1, -2 times 1 is -2. Add that, that's -6. That's a positive 12. That's a positive 10. -2 times 10 is a -20. And look at there. I have another remainder of 0. Okay, so we now know that this is a root or a 0, and this is a root or a 0, but I'm not done. So now I have x squared minus 6x plus 10. Can I find two numbers that multiply? See, where am I at? Okay, can I find two numbers that multiply to a positive 10 and add to a -6? So let's look at all my 10. So if I have 2 times 5, that's one option. I have 1 times 10. And so the answer is no. I cannot find two numbers that multiply to a positive 10 and add to -6. So I'm going to have to use a quadratic function. And so I'm going to do that over here, and I'll have negative b, which is a positive 6 plus or minus the square root of b squared. -6 squared is 36 minus 4 times a times c, which is 10, divided by 2 times 1. All right, so 6 plus or minus 36 minus 40 gives me the square root of -4 over 2. Plus 6 plus or minus, let's see, square root of -4 is 2i. So I can also, I'm going to do divide by 2. Let's see, I'll do it in 2 steps. Plus or minus 2i divided by 2. Both terms of the numerator are divisible by 2. So I get 3 plus or minus I. That's 2 zeros. And what were my other ones? -4 and -2. So total number of zeros are 2 real and 2 imaginary, for a total number of 4. Okay, we're going to do the same thing. So we will have plugged this into our calculator, and the graph that you see right there is what you're going to get after you've adjusted your windows. Notice how big this window is. Let's see, this looks like this is 100, -100, 300, 350. This looks like a positive 400, and it looks like the tick marks are 50. This is a positive 3. This is a -7, and the tick marks are 1. And I can see that it looks like I have a 0 at -3. X equals -3. All right, so let's test that. So -3, don't have to switch the sign if it's the 0 format. So I have 1 for the fourth, 6 for the third, 13 for the squared, 24 to the 1 power, and 36 as my coefficient, my constant, or x to the 0 term, and then I'll start my process. So I get 1, -3, I get 3, I get -9. Did I do that right? -9 plus 13 gives me a positive 4. -3 times 4 is -12. 24 plus -12 is a positive 12. -3 times positive 12 gives me -36. I have an answer of 0. That is what I wanted, because now I know that -3 is a 0. Now, I just want to remind you about something. If you recall, when we worked with a function the function value y equals x squared, it was a parabola. It looks something like this, right? And if it had moved over to the left or to the right, we were able to use our translations and dilations such that y is equal to, let's say, look at where this one moved. It moved over to the left to -3, potentially. Then what would happen was we would have a positive 3 within the function rule because it was in the x direction. So that's inside the parent function rule. So if that's the case where I have x plus 3 squared equals 0, that's the same as x plus 3 times x plus 3 equals 0. X equals -3 is a duplicate. We would potentially have two zeros at x equals -3. And so how we're going to test that is we're going to divide out another -3. And if I get a remainder of 0 again, then I know that it was a duplicate. So let's try that. -3 times 1 gives me -3. 3 times plus that gives me 0. This gives me 0. 4 plus 0 is 4. -3 times 4 is -12. And sure enough, -3 is a duplicated factor. Okay, a little bit, I would say advanced, but nevertheless, that's how you might want to think about it. So now what am I left with? This is x squared plus 4. And what are we trying to find? What was my instructions? I need to find all my zeros. Well, right now I have 2, and I need to set this equal to 0 and solve for x. And so I get x squared equals -4. I take the square root of both sides, and I find that x is equal to plus or minus 2i. So what are all my zeros? I have -3 and plus or minus 2i, and those are my zeros, and 3 is duplicated, which would give me a total of 4 roots, which is what I would expect. All right, I understand. I didn't see that either at first. Okay, next. Here is my graph. If you would have plugged that in, so this is one of your turn. So if I were you, I would go ahead and pause your video, enter this into your calculator and try this on your own. All right, welcome back. So what did we see when we entered this into our calculator? We see quite a few that I don't really know. So I have actually 4 locations where it intersects the x-axis. But notice these two over here to the left. They're not very convenient whole numbers. These two on the right do look like whole numbers. That looks like 2 and a 4. So I'm going to test, is x equal to 2, question mark, and is x equal to 4? Are those my zeros? Well, how do I find that out for sure? Well, I divide them out. If I get a remainder of 0, then I know that they were zeros. So what do? I take that and I plug in all my coefficients here, and I get 1, I get 2. Oh, no, I got, let's see, -29, -2, and +88. And what am I dividing by? The first thing I'm going to divide by is 2. So I pull down my 1, I multiply, I get a 0, I multiply, I get, and then I add, I multiply 2 times -29. Okay, I see a mistake. Let me just go back and fix it. You're probably thinking, Ms. Crary, you lost your mind. Okay, 2 times 1 is 2. Now I add 2 plus 2, that's 4. 2 times 4 is 8. -29 plus 8 gives me a -21. -21 times 2 gives me -42. -42 plus a -2 gives me -44. 2 times -44 gives me a -88 with a remainder of 0. Okay, perfect. 2 is a 0. X minus 2 is a factor. All right, let's try the 4. Let's see. I get a 1, I multiply, I add, I multiply, gives me 32. 32 minus 21 gives me a positive 11. 4 times 11 gives me a positive 44. What do I add those two together? What is my remainder? I get 0. That means 4 is a 0 or a root, and x minus 4 is a factor. What am I left with now? I have x squared plus 8x plus 11. Can I find two numbers that multiply to 11 and add to a positive 8? And the answer is no. So I have to use my quadratic equation. And so what do? I say, okay, negative b, so negative 8 plus or minus the square root of b squared, which is 64. 8 squared is 64, minus 4 times 1 times c divided by 2 times 1. So if you recall, a is equal to 1, b is equal to 8, and c is equal to 11, okay? All right, so 64 minus 44, that will give me 20 under the radical, so negative 8. Not sure what I'm doing. Plus or minus the square root of 20 over 2. Square root of 20 breaks down into 4 times 5. Square root of 4 is 2. That simplifies into negative 8 plus or minus 2 times the square root of 5 over 2. Both items in the numerator are divisible by 2, so I can simplify that further. That gives me negative 4 plus or minus the square root of 5. So what is the instructions? Find all the zeros. So I have 2, I have 4, and I have negative 4 plus or minus 5. So I'll rewrite that. 2 comma 4 comma negative 4 plus or minus the square root of 5 gives me a total of 4 zeros, which is what I was expecting. So these values right here were the negative 4 plus or minus the square root of 5. Okay, moving on. Complex zeros, okay, always occur in conjugate pairs for polynomials that have real coefficients. I'm not sure if you've realized that or not, or seen the pattern. So let's look at the complex conjugate theorem. Let a and b be real numbers and b be something that is not equal to 0. Okay, so we have an actual imaginary part, right? So if we have a plus bi as a 0 of the polynomial function, that means x equals a plus bi such that y is equal to 0. Then we also know that we're going to get a minus bi is also a 0. Okay, so here's an example. If I have 3 plus 4i, which is a 0 of that polynomial, then we know that 3 minus 4i is also a 0. So how are we going to use that information to help us? Well, we're going to go backwards. So we are given a polynomial function. We are told to write the polynomial function of least degree, okay, with integral coefficients if the zeros of the polynomial include x equals -1 and x equals 5 minus I. And this is our complex 0. Well, if x equals 5 minus I, then x also has to equal 5 plus I. Okay, that's what that theorem just tells us. So we have 3 zeros. So recall, but if I have a 0, that means x equals c, then x minus c is a factor, right? And we had a whole bunch of factors here. So we're going to go backwards. So we need to write these in factor form. So let's take this first one right here. How do I write that? If that is a 0, then I have to subtract it from x. So x minus a -1 gives me x plus 1. Okay, so that is a factor. Now let's do, well, I should have just left it. So here's where I got that one. Now let's do that 5 minus I. So I got to subtract it from x. So I take x minus 5 minus I. And then I got to do this one. And I take x minus 5 plus I. Now we have to simplify that. And we're going to, oops, excuse me. We have to carry the negatives through. So let's rewrite this. X plus 1. We're going to get x minus 5 plus I. And then we're going to get x minus 5 minus I. So that's what I have to work with. I need to put this in polynomial function form, and that is in factored form right now. So I have actually got to combine all this. Now, here's a trick to make your multiplication easier. Okay, I gotta, instead of multiplying two trinomials, this is in the format of a plus I times a minus I, where a is equal to x minus 5. So we are going to multiply first this as a unit. And so what do I get? X minus 5 times x minus 5 is x squared minus 10x plus 25. Then hopefully you see that if I multiply this unit times a negative I and that unit times a positive I, they cancel. And so I don't really need to worry about that. Then I can multiply the positive I times the negative I, and I get a negative I squared. All right, what is negative I squared? Well, negative I squared is equal to negative 1, so it's a positive 1. So let's again simplify. Don't forget your x plus 1 over here. 10x, so I've got 25 plus 1, so I have 26. Now I need to multiply each term by x, and then I will need to multiply each term by positive 1. So let's do that. I got x cubed minus 10x squared plus 26x, and then I have x squared minus 10x plus 26. I need to add them. X cubed, I get negative 9x squared. I get plus 16x plus 26. And unless I did something wrong, that is our answer. X cubed. Yep. Okay. All right. Let's try another one. Write a polynomial function of least degree with integral coefficients if the zeros include 4 and 3 minus 2i. Well, the complex conjugate theorem tells me that if 3 minus 2i is a factor or a 0, then I also, not a factor, a 0, then 3 plus 2i must also be a 0. And then I will take 4, and that will give me x minus 4. I will take 3 minus 2i, and it will give me x minus 3 minus 2i. And then I will take 3 plus 2i and subtract it from x, and that will give me x minus 3 plus 2i. Now I have to distribute my negatives. And let's rewrite that. X minus 4, x minus 3 plus 2i, x minus 3 minus 2i. Now I have to multiply these two trinomials, and I'm going to focus on the fact that this is a single term. So it's more like a plus 2i times a minus 2i, where a is equal to x minus 3. So if I multiply, let's just go ahead and bring my x minus 4 down. X minus 3 times x minus 3, I get x squared minus 6x plus 9. And then remember, if I look at this times negative 2i and this times positive 2i, you're going to cancel. So I don't have to worry about those. Now all I have to do is multiply 2i times negative 2i, and that's going to give me a negative 4i squared, which equals a negative 4 times negative 1, which equals a positive 4. So I'm going to add 4. Okay. Now I have to multiply through by x by each term. Oh, let's combine 9, and 4, which will give me 13. All right, and then I will multiply by -4 through the whole thing. So I'll do x first. So I get x cubed minus 6x squared plus 13x. And then I get -4x squared plus 24x minus, why can't I do that one in my head? 52, I believe. Let's double check. 4 times 3 is 12. Yep, 52. All right, I get x cubed negative 10x squared plus 37x minus 52. And that is my answer. All right. All right, try one for yourself. Welcome back. If I know that 3 is a 0 and 1 plus 2i is a 0, so is 1 minus 2i per the complex conjugate theorem. So now I have to create a polynomial. So I take x minus 3 times x minus 1 plus 2i times x minus 1 minus 2i. Now I have to simplify. X minus 3, I multiply through by that negative, x minus 1, negative 2i, and then I get x minus 1 plus 2i, and then I'm going to multiply that by considering x minus 1 as it's a single term. And what do I get? Let's bring down my x minus 3. I get x squared minus 2x plus 1. And then negative 2i times positive 2i gives me a negative 4i squared. I squared is -1, so it becomes a plus 4. I have to rewrite that again. Combine 1 and 4. And now I have to multiply through by x and -3. So what do I get? I get x cubed minus 2x squared plus 5x. And then I get -3x squared plus 6x minus 15. Add them. -5x squared plus 11x minus 15. I'll go check my work. Where's my answer? X cubed, 5x squared. Yep, that is the answer. We're good to go. All right, last thing. In the xy plane, the graph of the function f has x-intercepts. So those are the intercepts, or the zeros. Which of the following could define f? Well, we know that if these are the zeros, then x minus a -3, so +3. And then we know x minus a -1, so +1 are factors. And we know x minus 1. So let's go find where x minus 1 is. I got one there. I got one there, although it's squared. I got one there. I don't have one there. Okay. How about x plus 1? There's one. There's one. There's one. And then how about x plus 3? I'm sorry. Oh, there it is, x plus 3. And there's one. So the only option that has all 3 is C. That is the end of our lesson today. Reach out to me if you have any questions.